Sorry for the interruption because I ran out of my charge. I had to recharge my battery. As you can see, this is another one. I was second grade and I was 8 years old. It was 62 years ago. And this one is using permanent magnet. But the concept is the same. And this one has 3,800 RPM. That's a real powerful one. But like I said, they don't have a lot of kinetic energy. The reason why the mass is not a lot, the whole thing is about like 60, 70 grams. But the other ones, like this one, the mass is at least between 300 and 450 grams. And that makes a big difference when we're talking about kinetic energy or gain kinetic energy. So I show how this one works. This one doesn't have any connector, so I have to hold it by hand. You see how fast it starts? It's so fast. And then if you change the reverse or flow of current, it's going to go counterclockwise. You see how good it is? It can change immediately. See, 4,000 is a lot for such a small electric motor. It's just amazing. Okay, now we talked about the regular or ordinary DC motors. Now we talk about my invention, which has to do with the Lorentz forces, which is so important. And this is the one I did in 2004. And you can see this is a little bit different because you got 4 coils. And each one, I marked them, see, clockwise 1, counterclockwise 2, and then clockwise 2, counterclockwise. And the reason why I have the wire over the PVC, that is the only way. Because I'm not using any ferromagnetic like this motor, I have no choice. See, I have to have those. And this is the only way I could get the best magnetic force. And like I said, some of my coils are 1,000 Gauss, which is more than enough. Like this one has 2,000 on one side and 2,000, 4,000, and the 4,000 on this side. So it's almost 8,000 Gausses, which is more than enough. I have to mention something else. Few minutes ago, I talked about Lorentz forces, but unfortunately, the way my motor works is different because I could not find any round magnets. I'll show you. See, the only way I could use was a straight magnet like this, and then the rotor is only having Lorentz forces here in the center because the reason why this is not curved exactly the way the magnet, the way the rotor is. Let me show you. See, like this one is a round magnet. If I put this, see the difference? It's a big difference. So this rotor is exactly formed, and then the Lorentz forces are the effective, more effective. I show you this one has 7,500. Well, of course, this is not the actual magnets because this is using huge magnets like this, and the actual RPM, you may not believe, is 14,000, 15,000. Because I'm using a smaller magnet, And again, it's the same thing. It doesn't matter. The ordinary DC motors or my motor, always they are experiencing Lorentz forces. So this is supposed to, this is from the wiper of the Toyota. It's supposed to have a round magnet like this, not like that one. But anyway, it goes 7,000 RPM. The reason why it's almost half, because, like I said, it is using a straight magnets. So that is the disadvantage for my motor. Okay. Okay. This is the first one I made, and as you can see, these are the connectors, and each one has to go 180 degrees, see? And then as soon as one coil is energized, as I explained before, one is clockwise with respect to the flow of current from negative to positive, and immediately the other one is counterclockwise. But like I said, I can reverse it, and the dipole's orientation is reversed due to the flow of current. So that's the reason why once one coil is energized, the other one simultaneously, probably in a millisecond, is also energized, and it's going to be south, one is going to be north. And this one has a connector. All we have to do, I connect the positive and negative. And I have to mention something. My electric motor follows the same thing. Because it's using the Lorentz forces, it doesn't matter. If I change the flow of current, it's going to be exactly the same like this DC motor. It doesn't make any difference. It can go clockwise or counterclockwise. It's exactly the way I explained in my multimeter. If I have a positive charge, it's going to go clockwise. If I reverse this, it's going to be counterclockwise. It's the same concept. Unfortunately, this battery is a little bit low. I'm going to have to recharge it. Okay, let's see if I don't have to recharge it. Let me try something else. It starts so violently, I have to contain it. You see how violent it starts? It's so powerful. Now I'm going to have to put some screws here so it won't act like that. I'm going to have to contain this because it is so powerful. Okay, now it's contained. And as you recall, I was talking about my laser beam. This is the one who measures the RPM. And you see that? when it's reflected in that shiny things, it can go to 99,000 RPM. I show you. So now it's contained, hopefully it's not going to move. So the level how fast this goes. In probably 2 or 3 seconds it gets to 3,850. I have to contain this by hand again, see? I have to use another one which has the connector so I can show you how my tachometer works. This electric motor is a little bit different. It's like this one, but again, instead of using 4 coils, I use 2 coils, and each one is 400 to 450 Gauss all around. So this is almost like 5 centimeters. It's 400, 400, 400, 400, and as it gets to the edges, it's becoming 300, 200, but still it's so powerful. I show you. So I put the reflective mark here so we can measure the RPM, see? This is the reflective mark. Did you see how powerful it starts? Did you see that? This goes to 350, and this is the best I could do because all I did, I bought this gas meter, which is so important in my work, and then I could measure the magnetic field, and I got this tachometer, and even I weigh them, so I have an electronic scale. Let me show you. Even I have an electronic scale, it shows 1/10 of a gram, which is more than enough for my job. Some of them are like 61.2 grams, some of them are 65.1 grams, and so on and so on. This is another one, and this one goes 3,800 RPM, but this one has a connector, you can tell. I turn it this way so you can see much better. This way. So I have to contain because they're so fast. In less than a few seconds, it goes 3,000, 4,000 RPM. And as you can see, some of them, I use the big PVC, which is 4.5 centimeters, and some smaller one. This one has the big, and then I show you. This one maximum goes 3,950, but you can see the gain kinetic energy after the electricity is cut off. At least it rotates 10 more seconds. The reason why I explained before, it has moment of inertia, also this big rotor, and then it gains kinetic energy. And this is the best I could build. I built this few days ago, and honestly, I could go up to 7,000 RPM in few months. Like I explained before, it was 2,800, but this one has 7,000 RPM. The reason why you can see, I got 4,000 gauss. So each one is 1,000, and you see how big the coils are? And instead of 4 magnets, I used 5 magnets, and you can tell. So I'm going to measure the RPM so you can see. Hopefully you can see it from here much better like that. I think it's better if I do it like this. That's so powerful. I have to hold it by hand. If I don't contain it, they're going to run away. So I have to contain it by hand. It goes 7,350 RPM. That's extremely powerful. This is the best I could make. Well, of course there are more. Don't have to explain all of them. Like this one goes 4,000, and this one goes 4,500. As you can tell, some of them are round, some of them are rectangle. But in order to prove how versatile and indispensable my electric motor was, I did some experiment. I removed the S, so I just wanted to show you how, if you remember I explained that the left side is independent from the right side and vice versa, because each side is working independently. So this one, as you can tell, one magnet is missing completely. If you do it on a DC motors, it's not going to work. But this one is so powerful because it doesn't have to reverse the flow of current, so it works. And you may not believe, even though this one side magnet is removed, it goes almost 4,000 RPM. So it's a lot for having only one magnet goes 4,000 RPM. And I did something else. This time, not only I removed one magnet, but also I removed one coil. As you can see, only one coil is energized. See, that coil, this coil is not energized. The reason why I have this, because it's going to bubble. So this has to have on both sides so it won't bubble. So if it's not here, it's not going to rotate real good. And this is keeping the balance, in other words. And this one has only one magnet and one coil, because that coil. The reason why I want to show you this, because I want to see, you guys can see how important, how powerful the Lorentz forces are. See, even though it's only one coil is energized and only I have one magnet, it goes 2,400 RPM. I have another one. This one is the same weight, but this one is using the bigger PVC, and as you can tell, this coil has been disconnected and only one coil is connected. And like I said, it has to be so powerful in order to compensate for the second one. I'll show you. I have to make sure that coil is facing the magnet, otherwise it's not going to work. But see, This one is also going 3000 RPM, even though it's only one coil and one magnet. I have to show you something so important. As you can tell, this is an alternating current for the household items. And you can tell the gap is almost 1 millimeter, but in my electric motors are almost 5 millimeters. That makes a big difference. And in fact, you never ever see a straight magnet like this. You never see in any electric motors, because I had no choice. So as you can see, it's following the same principle. The magnetic force is always perpendicular. The Lorentz forces are always perpendicular. And you can tell this is almost 160 degrees, 150 degrees. That is a lot. But mine is not that much. And as you can tell, there's another factor. This has more poles. So instead of mine is energizing every 180 degrees, this is energizing every 30 degrees. It's 6 times less. So hopefully when we start our electric motor, it goes in a mass production, the factory can make it. And I show you here. See, mine is like this. See, mine is like this. And imagine even a millisecond makes a big difference. It has to go 180 degrees, 180 degrees. I was assuming if it goes in a mass production, we can do 90, 90, 90, 90. So that makes a big difference. That will rotate at least a millisecond, which is so good in my case, much faster than the one I have. And even we can go to 8 poles, see, 45, 45, 45 all the way. That will be 8 poles, but unfortunately I don't have the tools. And then, if it goes in a mass production, the factory can do this because they have the tools at their disposal. See, my connectors is not as good as this. This is the one, it's called brush. It's used for the AC and DC motor. This also can be used for my connections, which is the best thing. This is like a carbon, and there's no sparks, anything, but I'm using the brass, which is not as good as this anyway. So hopefully, like I said, I have so many projects in my mind. I can improve this, and like I said, if I have the tools, but unfortunately, I don't have the tools, and this is the best I could do.